In this video, we'll be talking about the sensation of hearing. By the end of the video, you should be able to understand the physical features of the sound wave, as well as how those physical features translate into what we perceive, the psychological aspects of what we perceive, that perceptual experience of sound. So the energy or the stimuli for hearing are sound waves, and sound waves travel through the air and they have very similar properties to light waves. We have a wavelength that travels from crest to crest. We have an amplitude that travels from the trough to the crest. So the amplitude is how high the wave is or how large it is, and the wavelength is going to tell you how frequent the wave is. And again, these sound waves, these vibrations travel through the air into our ear and then work as that last video talked about, hitting hair cells in the ear and so on and so forth. So now we're going to talk about how those psychological aspects of hearing come from those physical characteristics of the wave. And the first is pitch. And pitch is related to the wavelength of the light, the frequency of the wave. So let's demonstrate here how the frequency or the wavelength relates to pitch. That is measured in hertz. The next psychological aspect is loudness, and this is related to the amplitude of the wavelength. So how high that wavelength is. So let's watch this video to see, or this snapshot to see what we mean here by loudness and amplitude. You see, as the wavelength or the amplitude gets bigger, the sound gets louder. That is going to be measured in decibels. The timbre is related to the complexity of the wavelength, so the number of different wavelengths there are. A pure tone is only going to have one wavelength, but that is rare as it is in vision. Maybe on, if you've ever seen those like little tuning, I would call it a harmonica, but the people leading singing and musicians might use. That might give you a pure tone. Noise is going to be the presence of many frequencies that aren't in harmony. And when you hear all of the frequencies in the sound spectrum, that's what's considered white noise. Now let's talk about the localization of sound. How do we determine where a sound is located? It's much like binocular vision that helps us determine distance. Having two ears also helps us determine distance and localization. Depending on where the sound is coming from, it's not going to be identical as it arrives at both ears, unless it's right in front of you. So if the sound source is right in front of you or directly behind you, it will arrive at both ears at the same time. However, if it's off to the left, it's going to arrive at the left ear first and the right ear second. And your brain can calculate the loudness, the timing, and the phase to determine the sound's location. Thank you for listening.